So we've talked about the effect size, we talked about the confidence interval. There's only one last thing to talk about before we can move on to our next hypothesis test, and that's statistical power. So power is the probability of correctly rejecting the null hypothesis. In other words, in saying that there is a difference between our two populations. So in this case, between our new training and our old training. So we want to reject the null hypothesis. We want to increase the probability of correctly rejecting that null hypothesis. And so we call that power. The more power I have, the more likely I am to correctly reject the null. So the proportion of the comparison distribution that's in the critical region is what power represents. And so if we were to draw both distributions, one for each of our groups, so one for our old training and one for our new training, and we were to overlap them, we would want to calculate the percent of the population based on the new training that would fall within the critical region of the old training. And the more of that distribution of the new training that falls within that critical region, the more power we would have. So we don't need to calculate power in this particular class. We could do it with a z-test. However, it becomes a lot harder with the other tests that we learn. And so there's no point, at least in my opinion, to spend the time calculating power for one test, but then not do it for the other test, because the other test would require computer software and we couldn't do it by hand. So we'll just talk about conceptually what power is and how we can increase power. And actually, we've talked about these before. We've talked about these with the hypothesis test, and so I don't think any of this is going to be new, but we'll just reiterate it for each of these three different ways that we can increase power. So the first way that we can increase power is by increasing the alpha. So in other words, if I increase my chance for a type 1 error, then I'll make it easier for me to reject the null hypothesis. And we demonstrated this earlier. We demonstrated this on Thursday, that if I increase my alpha from 0.05 to 0.10, in other words, increasing my chance for a type 1 error from 5% to 10%, then I move my z critical value closer to the mean. And if I move it closer to the mean, then it becomes easier for me to reject the null hypothesis. I don't need as much of a difference between the sample mean and the population mean for me to reject the null hypothesis. Now the problem with doing that is that if I move that z critical closer to the mean, or to a z-score of 0, to the average, then I increase the risk of a type 1 error. So in other words, I increase the chance that I'm going to be wrong when I reject the null hypothesis. So if I increase my alpha from 0.05 to 0.10, I am doubling my chance for an error. I'm going from 5% chance for an error to a 10% chance for an error. So that's not ideal. So increasing the alpha is not the best way to increase our power, and it's the least desirable of our three. The second method is by using a one-tailed test. So what's nice about a one-tailed test, as opposed to increasing alpha, is that we leave the type 1 error rate, or the risk associated for an error, we leave that the same. So that doesn't change. So all we do with calculating a one-tailed test is we move the probability from the other tail. So if I have a two-tailed test, I have two critical regions. I move the probability from one of those tails to the other tail. And so that moves my critical value closer to the mean. However, it keeps my error rate the same. My chance for an error stays the same. Now that's not the most preferred method either, although it is better than just increasing alpha, but it's not the most preferred method either, because even though my type 1 error rate stays the same, my chance for an error stays the same, my test becomes less conservative, because again, I'm moving that z statistic closer to the mean, making it easier for me to reject the null hypothesis, making it closer, making the difference between my sample mean and my population mean not having to be so great. And so that's not preferred either. We want to have a conservative test, and we want to keep our alpha at the same rate. And the only way to do that is through this third point, or the third way to increase power, and that's by increasing the sample size. And so we talked about that a little bit earlier in our slide, that if we can increase our sample size, then we can reduce the standard error, we can reduce the fact that people are different from each other, we can minimize individual differences, reduce the variability, increase reliability, and give ourselves a better chance for validity. So in the process, we are increasing power. What's nice about increasing sample sizes is that our alpha stays the same, and our z critical value isn't affected, and so it doesn't move closer to the mean, it stays the same. It's just our population distribution of means are now getting narrower. So it is the preferred method. But remember, as we talked about before, there's some limit to increasing sample size, that if we increase it too much, we reduce the meaningfulness of our hypothesis test, which is why we get an effect size. And so, of the three, if we want to increase our chances for rejecting the null hypothesis, if we want to increase our chances for finding a difference between our populations, the best way to do it, of the three, is increase the sample size. But like we mentioned also, too much of a good thing isn't good either, and so we have that other measure, the effect size, and a less biased measure, to make sure that there's some meaningful differences between our two populations. So when it comes to power, you should know the three different ways of increasing power. You should know which ones are preferred over the others, so know their strengths and their weaknesses. And you should be in pretty good shape if you know those things when it comes to the multiple choice on the exam. So now that we've talked about these additional analyses, let's go back to our practical decision. So now not only do we have a hypothesis test, we have some additional insights that might affect our decision, but now we have some additional calculations, in particular the effect size. So let's talk about what you should include when making a practical decision, especially for a worksheet or for an exam. So when you're making a practical decision, I want you to provide a decision. So in this particular case, we're asking, should Applebee's implement the new training program based on the sample? And so you need to decide whether that's yes or no. And so I'm looking for you to make a decision, to stand on the table and say, we will or we won't implement this new training program. And it doesn't matter to me what your decision is. You can say yes, you can say no, I don't really care. What I'm looking for is your argument for why you said yes or why you said no. And so in your argument, you need to support your answer with at least two statistical evidences. So in other words, you can talk about your hypothesis test, you can talk about your effect size, or you can talk about the reliability and validity of your variables. So two of those three would be just fine. Now when you talk about them, don't just say that our variable was reliable. That doesn't really tell me that you know what reliable means. So make sure you explain why you think or don't think the variable is reliable. Same thing that goes for your hypothesis test. Don't just say that you reject the null hypothesis or you fail to reject the null hypothesis. Tell me what that means. So if you reject the null hypothesis in this case, we're saying that our performance for the new training was greater than the performance for the old training. If we fail to reject the null hypothesis, then we're saying there's no difference in the training when it comes to performance. So tell me not only if you reject or fail to reject, but tell me or show me that you know what that means. And the same thing with the effect size. So just don't tell me that we had a small effect, but tell me what that means at the individual level. So in addition to your two statistical evidences, I would like you to add an additional insight. Something else that may matter to the decision of whether or not, in this case, if we implement this new training. So maybe you talk about the cost versus the savings of this new training program, and that might be important to your decision. Maybe you talk about the mission and vision of Applebee's, or what you might think that is and how it might relate to a decision of whether or not you implement this new training program or not. And so you're given quite a bit of creative freedom with this additional insight portion. So whatever else you think might matter, talk about it and support it in a way that supports your decision that you make when making your practical decision. And if you do that, then you'll do well on the practical decision on the exam. So those are the three things that I'm looking for. And again, I'm looking for your argument. I'm not so much looking for your decision. I want you to make a decision, but then provide a good argument as well.